All right, guys, let's warm up a little bit. So let's do this warm up. So suppose that the derivative, you come late and the derivative is 2x. What is going to be f of x to your best ability to guess? What is f of x? That should be very fast. Okay, Muhammad, thank you. And what about the rest of you? Oh, hello, Christian. Nice to see you. Hello, Pavel. To the best of your ability, I mean, make the most general guess. Because I see you're writing x squared, but maybe there are other possibilities than just x squared. And yes, Alan, plus c. Okay? So I'm going to now say something very important. Are you ready for it? So your guess is x squared plus c. Am I right? If that means any constant, you do not know if the constant is 0 or minus 10 or plus 16 or who knows what other values are possible. Yes, but your best guess is x squared plus c. Now my question is this, guys, and maybe on first glance it looks like a weird question. Okay, suppose that I found some other expression, or let's say this way, can I find some very exotic function, something that I have never seen before, never encountered, and its derivative will be 2x? Will this be the entire set of the entire family of derivatives? Let me put it this way. Have you seen the movie The Usual Suspect with Kevin Spacey? Who has seen this movie with Kevin Spacey, Usual Suspects? Kaiser Soze, exactly. So my question is Kaiser Soze among our usual suspects? X squared plus c are the usual suspects. Who created this derivative? What was the function? The usual suspects are x squared plus c. Must Kaiser Soze be among those usual suspects, or perhaps there are some exotic alien functions that you have never seen before and their derivatives are equal to 2x. Do you understand my question? That's the question, right? So can I have another type of function, something that perhaps I have not seen before? And if you understand how to think about those questions, if you understand how to think intuitively, then you should know the answer to this problem. Right? If you're not just pushing symbols but understand, then the answer to this problem should become very obvious. All right, I don't hear answers, so let me perhaps guide you there. I also do not have visual on Minkowski, no visual on Minkowski. What is the derivative, geometrically speaking, right? So for instance, here is the situation where the derivative equal to 0. Yes, derivative of a function, sorry, derivative at all x, I mean. Derivative at all x is equal to 0, what must be the function? What do you think? If the derivative is equal to 0, what must be the function? And that's, yeah, it's a great question, but maybe to emphasize, could you say what shape is the curve going to have? What shape are we viewing? If the derivative is 0, what shape are we viewing? And then explain, yes, but say even better. A straight line? Yes, but what sort of straight line? A line that is what? Horizontal with respect to the x-axis, this type of thing. Yes, a horizontal line. Now, why is that the case? Would anybody like to explain? How do you know that this is the case? Yes, slope, right? So how do you know this is to be the case? Well, if you think about what derivatives mean geometrically, it's like what you do when you look at a curve. You look at a curve and you imagine it's built of many microscopically small. Here I make the drawing so you can see them. Many microscopically small line segments, right? That would be a good approximation to what you do when you take derivatives. And let's say in the middle of that line segment is where you carried out the measurement. You understand? So basically, where do you see the x's, right? So you have, this is the xy coordinate system. And when you say at any x, the derivative is 0. So for example, you might say at this x, the slope of the line observed on the graph for this x is 0. You understand what I'm saying, guys? That's very important. So that tells me that how can it happen? That means if the derivative is everywhere 0, it means that all the line segments building up this curve, they are all horizontal. Do you see that? They're all horizontal. Good. Similarly, if I have that the derivative is equal to, let's say, some number 5, it means all the line segments have slope 5. So that means that my function must have been 5x plus y plus c, because you see, if I lift the curve up or down, it will not affect the slope. Do you agree? It will not affect the orientation, the relative orientation of the curve, up or down. Good. So what will happen with any other curve? So suppose that we have this very nice, beautiful contour, right? This very nice, beautiful contour. Now, what if I have the coordinate axis? What am I going to really imagine this to be when I think of derivatives? I imagine this to be made of many line segments. I purposefully made them large, but if there are many line segments, millions of line segments, you will not be able to tell it from the actual curve. You understand? If you make the line segments sufficiently thin, sufficiently short, and many of them, it will look to you like the curve. In fact, if you zoom in on this curve, it's made out of pixels. Do you understand the idea? Yes. Similar thing is, how do I know that our motion is continuous? I'm watching the screen and I'm seeing you alive and breathing and moving, but really it's a succession of pictures, maybe 60 frames a second, maybe a little more, but just a few frames a second. Okay, so this curve is built of many line segments. Agreed? And now the derivative of this function is given to us, right? So we know the derivative. The derivative is just what it means is this. It's just if I look at some x, then this is going to be, it's the slope, right? This slope. You see this? So this slope is going to measure f prime x. It's the rise over run, f prime x. Good? So now my question is, suppose I found another curve. I found another curve g prime of x, and its derivative matched that of f. The derivative matched. What can you say about the relationships between those two curves? How are they related? Do you understand my question? I'm asking you, no, okay, why don't you understand my question? So derivative of two functions are the same. Here is one, derivative of f is drawn to you. And I'm saying there is another function, its derivative is always for each point is exactly the same. What does it say about those two curves? How are they related? How many of you study psychology? If you do, then perhaps, you know, somebody might help you. As Freud would have answered this question, he would have said, diese zwei haben eine verborgene Beziehung. In der Öffentlichkeit halten sie sich voneinander in Abstand, which means these two have a hidden relationship. They keep their distance from each other in public. What is Freud talking about? Christian, you hit it on the nail. Exactly. Exactly. That's what everybody should have noticed and talked about. What is the relationship between those two functions? If they have the same derivative, the derivative talks about slopes. It talks about the orientation of those minuscule line segments, right? So everywhere I look, the minuscule line segments are having the same what? Complete my sentence. Are having the same slope. And if they're having the same slope, what could possibly be the relationship between those two curves? Right here, let me try to draw one relationship where you have the same slope. Look at it. Here is one, right? Those two lines are the same slope. Here is the next two lines having the same slope. Here is the next two lines having the same slope. The next two lines having the same slope means they are parallel lines. If they have the same slope, they are parallel. Here are the next, the next, the next. The next, and the next. Right? What will I trace if, of course, I bother to draw the picture well? They might intersect, of course. I mean, they could be parallel and touch each other if, of course, there is no distance between the two curves. You understand? But there, how can the contours, the shape of the two curves must be the same. Now, what was that Abstand? What was that distance that Freud was talking about? Abstand, it means standoffishness, stand off. Do you see this? That is the distance. That is your constant C. Do you understand? That's the constant C, which could be equal to 0. Do you understand? The constant could be equal to 0. They might be matching curves or they might be parallel curves. Do you understand what I mean? If you understand geometrically, if you understand this principle I'm trying to teach you, then without any sophisticated formulas, you right away know that the result is true. Make sense? You just, because it's obvious, you see? It's so clearly obvious what's happening here. How many of you understood my explanation? It's terribly important. They would not just touch Zohib, they would be the same curve if the distance is 0. And the way to prove it, you can use, for Calc 1, you can use the intermediate, sorry, not intermediate, the mean value theorem, which I'm sure you already know about because you watched my lectures, right? You watched the lectures that I emailed you from my previous class where I scream at my previous students. So you know what it is like. Yes, you might have the same M, you're right, James, but a different B. That B is, I called C in this particular case. Exactly. So, of course, you have to check all my videos, right? That's what it's about. Becoming famous, making money on those beautiful calculus videos. What's more popular are more translations from German. So, do you understand, guys, what it means? So, for example, suppose that I found that the function f prime of x equals to 2x. We return to that. Then you are guessing that the function f, you might guess that one function, let's call it f0x, you might guess it, one function is equal to x squared. 0 means that the constant is 0. Good? Now, if I find that another function, if I find that another function g has derivative equal to 2x, what can you say about g of x? What's the relationship? G of x must be what? Well, Zohib, you're saying it must be the same function. Must it be the same function or may it be different? What did our previous picture show? Exactly, June, right? Look at the previous picture. Two functions can have the same derivative, and all that means is that the lines are parallel. They have the same slope. Every curve is just a sequence of lines, a chain of line segments. Yes, it is a chain of line segments. And if the slopes are the same, those line segments are parallel, which means those curves are parallel. Yes? Which means if you take any 2 points, if for any particular point x, you have 2 points on the curve, the distance between those 2 points, let's say f of x and g of x, will be that constant c. Yes? I'm saying the distance between those 2 points will be g of x minus f of x will be always the same constant c. Could be negative or positive, yes? So what does it tell us? It tells us that g of x must be equal, are you with me, guys? X squared plus c. It must be very similar to x squared. Might not be x squared exactly, but cannot be very different. Kaiser Soze is among the usual suspects if you watch the movie. If not, make sure to watch the movie. My God, you are Americans. You don't even watch good movies made in America. There are few of them, but there exist. That was not a bad movie at all. You should definitely watch it. Yes? Back to the lecture. Do you now understand what Freud is meaning by his sentence? What does he mean by that analysis? Remember, these two have a hidden relationship, but they keep distance in public. Why? Because what's the distance in public? That's the constant c. The hidden relationship is that they are tangents to one another. They are touching each other at a distance. They are parallel to each other. Is that clear? Confirm if that's clear, guys. We need to move fast. I do not see most of your faces. I have delayed response. So I see 3 people said it's clear. What about the rest of you? Maybe 5, 6. Only 15 people understand this. Out of 26, only 15? I'm gonna bully you until you say yes. Derivative means slope. Slope, if you have 2 curves that have the same slope, no, 2 line segments that have the same slope, they are parallel. Yes, makes very obvious, easy sense. Understand? All right, so here is that verborgene Beziehung. G of x minus f of x is a function k of x. K prime will be 0, which means k of x is a constant, which means g minus f is a constant, which means g is equal to f of x. So here is what I'm trying to say here, guys, right? So suppose you went to an alien planet and you discover this odd looking function. I mean, I drew some strange artifact here. And then for that artifact, you find that the derivative is equal to 2x. What is this function in essence? Write in the comments. You see, just some weird looking function, something in disguise. Exactly, Brandon. You got it. So in essence, this function is like what? Why so few people are writing? It should be exploding. I should be seeing text. I should see 100 text. Even I have 20 students, I should see 100. Exactly, Alan. We'll see if you understand this. And then today in the evening, I will see how good you become at playing what, when, where, right? I want to show you another question, at least one more, and see how good you can answer those questions. All right, good. Very important. This is, if you watch the mean value theorem, you can actually establish this result using mean value theorem. Now, let's give a preview of what they call U substitution. Now, it's a bad name. U substitution, really, the better name would be reverse chain rule. Reverse chain rule. Are you with me? So let me see how good you are without me even explaining this, right? Suppose the derivative happened to be cosine of x squared times 2x. My question is, what was the original function? So you come late. You see that the answer is cosine x squared times 2x. The class was about differentiation. What was the function that you differentiated? Okay, that's amazing. I see already 3 people are answering it. That's good. 4, wonderful. Why not 5? What about the butterfly? Okay, David, I presume so. Okay, good. I have how many answers? I have 1, 2, 3, 4, 5, 6 answers. And there are 20 people here that they haven't answered anything. Okay, cool. Well, don't look into their answers. You see, I understand that you don't want to repeat, guys. Don't look at their answers. I want to see that you follow, so that I know that I don't need to explain more. Right? So it's a bit hard to gauge since I don't see your faces. Good. So here is the situation. Let's learn what the situation is about. No, Rafid, I will explain why not. Okay, so here is what happens when you use chain rule. What is chain rule? So let bx denote big fish, the outer function, and sx denote the small fish. So what will the derivative look like? Are you seeing this? Derivative of b of s of x is b prime, and then you see the inner fish times the derivative. Now look at it very carefully, guys. That means that if you look at the result, you see the inner function and its derivative. All you have to figure out is the antiderivative of b prime, because you see you can ignore this. It pops out. You can ignore s prime, and this is in its belly. That's what you have to place. But you need to figure out the antiderivative of this expression. So, for example, in our case, b prime is cosine. The derivative is cosine. Why do I think so? Because I see x squared and I see 2x. And if I say this is the inner, the small fish, I see its derivative on the outside. So I know that I can ignore it. All I need to do is focus on cosine. And what's the antiderivative of cosine? It is sine x squared. And I add plus c because I need to include all my usual suspects. You will see soon enough why that has to be the case. I have to be sure to include all my suspects. It could be sine x squared, but it could be sine of x squared plus 5, or plus 11, or plus pi, or plus any number. And those are the only possibilities. You understand how we figured out its only possibility? Because every other curve that matches the derivative must be parallel to this curve. Do you understand that, guys? Yes? If it must be parallel, it must be the same function. Very powerful ideas, very useful ideas if you can apply them. So what about this, guys? What would you do now? Now your task is to find the antiderivative of cosine x squared times x. What could have been the function if the result of differentiation is cosine x squared times x? Careful, James. So Christian, yes. Nassim, you give the same answer as before, but the derivative of sine of x squared is cosine x squared times 2x. So how do you think of this? You look at this expression and you think, what's missing? For this to be a full result of chain rule, I see that the inner function is x squared and the derivative should be 2x. You understand? The derivative should be not x, but 2x, because that's the derivative of x squared. So I put the 2 here, and to compensate, I multiply by 1/2. I cannot change the expression without compensation, yes? So it's 1/2 cosine x squared 2x. And now I look at cosine x squared 2x, and that's a perfect chain rule. Do you see that? Perfect chain rule. The antiderivative of cosine x squared times 2x is sine x squared. So the result is 1/2 sine x squared plus c. Do you get it? You have to not just get it when I say, you have to recognize it instantly when you see it. You understand? Instant recognition is what we are going to train. So first of all, let's introduce notation. This is mathematically how you are asked to take antiderivatives of a function. You have this integral. Zohib, what would you like to hear? So I see that cosine x squared times 2x would have been a perfect result of chain rule. So I put a 2 here because I only have cosine x squared times x. So I put a 2x here, and to compensate, I multiply by 1/2. Yes? To compensate, I multiply by 1/2. And then I take the antiderivative of cosine x squared times 2x, and the result is sine x squared times 1/2. You understand why I know that? Because derivatives, I can skip a constant when the constant is multiplying. I can skip it, and I can take the derivative. So all I have to do is guess the antiderivative of cosine x squared times 2x, and then multiply it by 1/2, and that would work. You all understand that? And now notation is the following. So integral, it's called integral of f of x dx. It means find me a function whose derivative is this f of x. So for example, when I say integral 3x squared dx, the reason for the notation, it will become clear soon enough, I hope, why they use this notation. This stretched out integral sign is s. So it's a sum. That's why it's supposed to remind you. It's Leibniz notation. It's now something that Leibniz introduced. So for instance, the integral of 3x squared, dx is simply find the antiderivative of 3x squared, which is x cubed plus c. Good. The integral of 5x squared plus e to the x means simply find the antiderivative of this function. So that would be 5 over 3 x cubed plus e to the x plus c. Confirm that you understood what this notation means. Basically going backwards, right? And this is how you say it in calculus notation. That's it. Now notice that the following is true about those indefinite integrals. They're called indefinite integrals, this symbol. That the integral of a sum is the sum of the integrals. And the reason, of course, is because if I know the derivatives of each component, derivative of a sum is the sum of the derivative. So that really is just saying to find the antiderivative of f plus g, I just have to guess the antiderivative of f and add to it the antiderivative of g. Yes? That makes sense. Yes, guys. If I could guess the how to take antiderivatives of each piece, then I'm done for it. And this is why I could move the constant in and out. The antiderivative of constant times f of x. That's simply all I have to do is guess the antiderivative of the function, because the derivative can travel through the constant. What I'm saying, it makes sense to you. Yes, derivative can jump through constant. So it's like this. If I have let's say c times fx, and I take the derivative, then the result is c derivative of the function. That's the constant multiple rule. And it's not a rule because somebody told you it's a rule. It's a rule because you understand why that works. Right? We talked about derivatives for so long, I cannot slow too much. You have to remember, it's not zero, right? Because it could not be zero. Right? Let's say the derivative of 5 times x could not be zero just because people learn the derivative of constant is zero. No, right? You're measuring the slope of the function. All right, good. Now it's your turn. Let's see how good you are at guessing something known as U substitution, but without using U substitution, by simply looking at it and figuring it out. So do problem A. What's the integral of x squared times root of x cubed plus 1? You understand how you think. You have to recognize whether or not it could possibly be chain rule that produced this expression. So you have to be good at recognizing the animals. What animal ate what other animal? All right, guys, I give you one more minute. I have to move. Well, Muhammad, be careful. You are not going backwards the right way. Where do you see the x cubed over 3? You look at this expression. How did this expression came to be as a result of the derivative? That's what you ask yourself. All right, time is up. Let's solve it together. Muhammad, here. That's good. That's good now. Mary, very good. So here is the idea. Look at it. Let's do it carefully. So you have to recognize that it's reverse chain rule. You understand? Because all you're doing with antiderivatives, you're guessing based on your ability. Thank you, Alan. On your ability to look at it. So you see, we see a root here. And how my eyes are moving, I see x cubed plus 1 and I see x squared. When I see x cubed plus 1 and I see x squared, I know that might be the derivative. X squared might essentially be the derivative of x cubed plus 1. But it's missing something. If I took the derivative of this inner function, I need a 3. You understand? Rachel, you are shaking your head. What doesn't make sense?
So what did you recognize as the
Think you have Terminator vision. So you see this, you see something on the inside of the root. So root has eaten something. Agreed? It's not x, right? And then you check whether or not you see the derivative of what's inside of the root. You see, guys, you were not watching Terminator appropriately. Have you seen Terminator vision? You know, he has this outline, and that's pretty much how you're reasoning there. Good. That's what I am seeing. You see, maybe that's not true, you understand? But I check what's inside of the root because you see it's inside of the root. I see root has eaten something. Do I see the derivative next to it? And you see here I observe x cubed plus 1. So if that's true, I should observe 3x squared here, right? Are you with me? My God, what's going on with you? What do you even do, guys? You don't do mathematics and you do not watch Terminator. What is your reason to exist? Exactly. Well, sleep is 1/3 the meaning of life. If you read Remark, you would know the other two. So here is what you have, right? So the inner function, I see x squared. That's almost the derivative. So I complete it to be the derivative. I put a 3. If I put a 3, I need to multiply by 1/3 because I cannot change it. You see? So that's where you have the 1/3 here. And do you understand what I do next? The root function is essentially something to the power 1/2. So when I take antiderivative, when I do integration, I should see something to the power of 3/2 multiplied by 2/3. Do you agree? That's the antiderivative of this expression. Clear? Guys, do you understand what happened here? The antiderivative of something to the power of 1/2 will essentially be 2/3 and to the power of no problem, Mustafa. All right, I hope you can continue being here. So make sense? I just add one and I divide, or sorry, multiply by the reciprocal to cancel the 3/2 when it drops down. So here is what we are getting. X cubed plus 1 is the inner function to the power of 3/2 times 2/3, and there is 1/3 that was created by correction to correct it. You see, so the answer is 2 divided by 9 x cubed plus 1 to the power of 3/2 plus c. You understand? And once you train your recognition, it's done very fast. Now, please, if you understand that, solve B. Quickly solve B. Tell me what is the answer to B. What do we have over there? One answer. So careful, James. It was 3 here. So what do we want to have here? And what's the inner function? Inner function is not significant. You don't need to keep it. Nassim, write it. What you wrote is a bit confusing. I think you might have integrated. I'm not sure what you have done exactly. Mariam, you forget what should be inside. The inside is what? You have to have this terminator vision. All right, so let's do it together. Terminator vision for cosine is this, right? What's the inner? It's I see this pattern, right? I see something to the power of 3, and then the derivative of that something. That's what I need to see. Okay, so some of you are saying 1/4 cosine to the 4th, but you need to write it complete. Yeah, that's good actually, David. That's right. Sorry, that's almost right? So there is this one thing, is that the derivative of cosine, if this is cosine, then the derivative should be minus sine, not sine. So that's what I do. I put a minus here. You see this minus here, and this minus here is to compensate. Yes. So inner function cubed, the derivative is minus sign. All I have to do is just take the antiderivative of the outer function. The antiderivative of the outer function is to the power 4 multiplied by 1/4. So it's cosine to the power of 4 multiplied by 1/4, and this red negative is what survived because I needed to make it a perfect derivative of the inner function. You understand? That's why it's very useful to think symbolically. Look at it. If I have b of sx and I take the derivative, then I will get b prime sx times s prime x, which means that if I see this, the antiderivative is simply b sx. I don't need to consider this. I don't need that. I just need to find the antiderivative of b prime. Yes, that's correct, Zahib. That's absolutely right. Except, yeah, we did use x, right? Or did we use not? What did we use? We used theta. So you have to keep the symbol, okay? Because x is a different symbol. Make sure to use the same letters that that were requested, especially for the part. Not here. It's okay if you type it here, but possibly if for some reason on your final exam where you submit a digital answer, I will check your work. But if you submit a digital answer, make sure that you can put it like the computer will understand the answer if it's graded by computer. Okay. Let's go on. Another question. C. On keyboard, no, you usually have either if it's depending what software you're using. Probably if it's on the website, you have like a special menu where you can type theta. Here you can write X, it doesn't matter, or you can write TH for theta or something, right? But in LaTeX, when you write math papers, you have this symbol slash. And you say theta or something like that, and that will write the letter with dollar signs. But you're not using LaTeX. You're too young for it. All right. So okay. So Nassim, you have the answer for. That's good. That's very good for C. Nassim, very wonderful. Wonderful. And the rest of you were solving C. Fast, guys. I want to finish this lecture and move to higher and better things. We have so much to cover. Good, Minkowski, you get it. Is it difficult? It's not difficult, right? It's just especially if you understand the pattern, that's it, right? It's exactly, Alan. Don't waste time. If you solved it, you just have to think backwards. Exactly, very simple. Think backwards. Now, if you don't waste time, if you solve this, consider D. Quickly solve D because we don't want to waste time. I will go and explain now C. Very simply, cosine has eaten e to the x. A medusa has eaten the, what do you call it, the water snake. So inner function, and here you see a perfect derivative. So the answer is sine e to the x. Now your goal is to find D, guys. What is D? Can you see how to integrate D? One more minute. Careful, careful, James, not right. All right, time is to solve it. So here it is, guys. Simply notice that z squared divided by z cubed plus 1 can be written as z squared to the side 1 over z cubed plus 1. Yes? And now look at this. It looks like 1 over x has eaten z cubed plus 1. And the derivative of z cubed plus 1 is 3z squared. You see, z cubed, 2. So always look at powers. 3 and 2, that's a good combination. So z cubed plus 1, its derivative is 3z squared. So I don't have a 3. So what I do is I multiply by 3 and I factor out 1/3 because 3 times 1/3 is 1. And then I use this structure. You see, I can ignore what's in the box and I see simply 1 over something. The antiderivative of 1 over x is ln absolute value of x, where x is z cubed plus 1. So it's ln absolute value z cubed plus 1 times 1/3. Do you understand? It wasn't difficult, yes? It's just 1 over x that you took antiderivative for, and then plug the inner function. Okay, it's just a matter of recognizing this. Always pay attention if you see a polynomial, see if you can find the derivative of that polynomial. Here is a practice on how those questions can be made, okay? Look at A and B, guys. You have to place something in this box other than 0 and other than the reciprocal of this function to make the integration very simple and then calculate the integral. So for A, type what do you place into this box and then tell me what will be the solution if you put it in the box. Okay, I'm trying to make you see what must be, how to recognize chain rule. In A, what should be in this box? Very good, June. Very good, Rachel. And once you type what's in the box, you can do it in one line. Type what's in the box and then tell me what would be the antiderivative. So what's in the box, space, the antiderivative. Okay, Nassim. Careful, look at the function is sine that is that 8x cubed. So what's the antiderivative? Muhammad, yes, you're right, Muhammad. June, you made a small mistake. Okay, and the answer is, it should be fast. All right. Time. So because you see sine that 8x cubed, I want to see 3x squared. If I see that, I just need to find the antiderivative of sine, which is minus cosine of x cubed plus c. What do you place in b quickly? What to place in b, and tell me what's the antiderivative then. Come on, guys, I need to cover more material. Okay, so what you should have is the derivative of tangent inverse is 1 over x squared, and that's what we want to place there. And so the antiderivative is e to the power of tangent inverse plus c. Simple as that. All right, moving on. All right, so first we want to understand what is sigma notation. It's just a convenient way to describe a sum. So here I have k equal 1 to n of ak, and that means you add a1, and then you upgrade the integer to the next one, plus a2, plus a3, all the way until you get to n. So for example, the summation of 1 over k, where k 1 to 5, if I were to write it out, it will be 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5. You understand? You update k from 1 until it reaches 5. Now, here in B, it's 3 to 6 of 2 times k. So then what you have is 2 times 3 plus 2 times 4 plus 2 times 5 plus 2 times 6. And that's the sum of certain even numbers, 6 plus 8 plus 10 plus 12. Now, the next would be k from 6 to 6 of k cubed. That means I put 6 cubed here, and then there is nothing to update because that's it. As soon as I have 6, I'm already at the top, I stop. There is nothing special about the number, the letter k. It's a dummy variable. I could do this, j equal to minus 2 to 1 of j squared. And what is that? This is minus 2 squared plus minus 1 squared plus 0 squared plus 1 squared. You see, it's the sum of those squares. Good? Any letter will do. Now, what would be the summation if I start I equal to 2 to all the way to I equal to 6 of the number 5? What would you write? It is not possible. What's not possible? So Christian says 5, but look at it. First I is equal to 2, you write 5. Then I is equal to 3, you write plus 5 again. So you write a bunch of 5 plus 5 plus 5 plus 5. You see how it works. Until I reaches 6, you have to write whatever is here. And it could be updated based on the symbol. So you say 5 when I is 2, 5 when I is 3, when I is 4, I 5, and I 6. How many additions of 5 do we get? Look at it. We have 6 minus 2 additions that follow after 2, right? So 6 minus 2, it's the 4 that follow after 2. And then we have to add the 1 that is I equal to 2. So it would be 6 minus 2 plus 1 additions of 5. Good? Understood? Wonderful. So that's the sigma notation, only a matter of summation here. That's just only a notation for the sum. From where do I will also mention that later on, but look at it. 6 minus 2 are all the numbers that follow after 2. You understand? Not including 2. So 6 minus 2 is the additions not including 2, the ones that follow after. But then I also have to include 2. I will show you later on with this summation where that appears. Okay, then you have, let's say, s equal to minus 3 to 0 of e to the 2s minus 1. So then s will be upgraded from minus 3 until it reaches 0. Okay, do you now understand where you have the, okay, I'll get there later. I mean, think about it. Convert this to sigma notation. You can type in your text, you can say something like s bottom k equal to something, all the way to up, what's the number in here, of what expression. You can type something like this in your text. Okay, so what is a in sigma notation? What's this? So we write it like this. So s bottom is k and equal to something, and then what is k equal to first, and then where does it terminate, and what do you add up? Okay. Now I cannot wait too long, so I'm gonna go ahead. Of k, yes, Nassim, you're right. So here is the solution to a. So afterwards you can work through it and realize how that works. Okay, so I can say what I'm adding is first I say the integer begins at 2 and ends at 7. That's how many additions I have. First addition, second, third, fourth, all the way to the 7th addition. Second, third, fourth, fifth, etc. And what am I adding? I'm adding k, right? I can simplify 1 plus 3 plus 5 plus 7 plus 9 plus 11 as, for instance, those are odd numbers. So I can think of 2k plus 1. If k is equal to 0, it's 2 plus 1, it's 0 plus 1, which is 1. If k is equal to 1, it's 2 times 1 plus 1, which will be 3. So all I have to figure out is what's the biggest k, what it should be to give me 11. And clearly then k should be equal to 5. So it's from 0 to 5 to k plus 1. Okay? You follow what I'm saying, guys? It's just notation. Now if I have 2 plus 4 plus 6 plus 8, how do I encode it? I can write it as 2 multiplied by k, where k goes from 1 to 4. Because I see if k is 1, it's going to be giving me 2. And if when k reaches 4, I'll get a. And that's summation of consecutive even integers. If I am to add minus 2 to itself 4 times, it can be written as k equal 1 to 4, or just add minus 2. Something like 1/2 plus 1/3 plus 1/4 can be written as k equal to 2 to 4 of 1 over k. This means, again, start at 2, then write the expression instead of k. You replace 2, then you write plus, you upgrade k to the next value, and so on. Yes? So similarly, you do with the rest of the expressions. Now, again, the letter k is an example of something called a dummy variable. So we can exchange it with any other letter, and that does not change the meaning. You always have to pay attention to the meaning and not to the letters. What does it say? It's really the summation of the first integers that are divisible. Okay. So k equal 1 to 6 of 3k. All right. Well, if you have to go, you have to go. So always read the meaning, because different looking sums might mean the same thing. So for example, k 1 to 6 of k squared, it's just the summation of the first square numbers from 1 to 6. I could have written it also, if I wanted to, as k minus 2 squared, where k starts from 3 and goes to 8. You see why? Because let's say 3 minus 2 is 1, and then 4 minus 2 is 2, and onwards, right? And then 8 minus 2 is 6. Do you understand? I can write the summation in many, many ways, and it means the same thing. And always try to read the meaning and not the symbols. Now, the following properties are true, and they easily seem to be holding, right? So the sum from k equal to m to n of ak plus bk will be the sum of the ak's plus the sum of the bk's by themselves. And I can always factor a constant out of the sigma sign. Now, why is that true? Very simply, what does the summation mean? It means add up terms of the form a plus b for k going from m all the way to n. So it's am plus bm. am plus 1 plus bm plus 1. And you continue adding. So you can regroup the summation and have the a's added by themselves plus the b's added by themselves. Good so far? And then you can rearrange the summation, and it's the sum of a's plus the sum of b's. Similarly, c times ak just means cam plus cam plus 1, just c times each guy. I can factor the c, and I see that what's in parentheses is the sigma notation. It's the summation there. So here are some important sums. And here, if you haven't understood where the plus 1 comes from, I'm going to explain this again. So if I'm just adding a constant from k equal to n to m all the way to k equal to n, what am I truly adding up? Okay, so it's a plus a. How many a's am I adding? Now let's look at the those letters. So it's m plus 1 all the way to n. I can write them in a way that it would be easier for me to see how many additions I carry out. So it's m plus 0, m plus 1, m plus 2, all the way. How do I get to n? I need to take m and add to it n minus m. Do you understand? You see, the blue numbers are really useful for carrying out the count, to know how many additions are produced here. So then from the second term all the way to the last term, I have 1, 2, all the way to n minus m terms, n minus m terms. And then n minus m, there's this extra term that I haven't considered, plus 1 is going to be what the sum is equal to. It's n minus m plus 1. You see where the plus 1 comes. So you have to, when you add a constant to itself, you have to take the top number, subtract the bottom number, and add 1. And this is why. Look at it. We had 0, 1, 2, all the way to n minus m. Are you with me? Confirm that you understand so far. Good. All right, so then if you understood me, then let's consider the second, slightly more difficult summation. Are you ready for it? How do I add the first? And anybody celebrates Hanukkah here? I know one person left, but how many do I have that celebrate Hanukkah? All right, so a few of you celebrate Hanukkah. That means you will have to, or maybe just one. It means that in a few moments, we'll see if you understand this problem, okay? So we're adding up numbers like 1 plus 2 plus 3 all the way to plus n. And that's written compactly as the summation from k equal 1 to k equal to n of the letter k, which means put k 1, then plus update k to 2, plus update k to 3, and you continue updating it until you reach the top expression, yes? Now, what is the summation? So there is a legend that says that there was a cruel German elementary school teacher, and he did not despised his pupils. And he made them some numbers, 1 plus 2 plus 3, all the way to 100. And the pupils were just work at it and all give wrong answer except for one very special, very talented pupil. And, you know, at the time paper was expensive, so they wrote on small blackboards. They had like a blackboard, a mini blackboard on the desk where they would use chalk to write their solution. So only one, later to be known the Prince of Mathematics, Carl Friedrich Gauss, he used to be on the German mark before they switched to euros. He was on a German mark. At the age of 6, he could solve this problem instantly. He would say, here steht's, here it is, and the solution was correct. To the credit of this cruel elementary school teacher, he recognized his talent and he moved this pupil to, he notified about this pupil to the authorities. Germans like to do that as well. So how did Gauss figure this out so quickly? One possible way to do that is to observe this pattern. So I can write the summation. The sum is going to be 1 plus 2 plus 3 onwards and onwards until n, right? I can write it in increasing order, but I may as well write it in decreasing order. You follow? And then I observe that if I add the two rows, if I create addition by columns, s plus s is 2 s's. And the first column is n plus 1, the second column is n plus 1 as well. Third column is n plus 1. As this is, if you go to the right, there is a decrease by 1 unit, and over here there is an increase by 1 unit. So it's as if this row is donating a 1 to the top row. So they have the same number of integers among them, namely n plus 1. How many n plus 1s do we have? Well, 1. We can use the top row to count. 1, 2, 3, all the way to n. Yes, all the way to n. So we have n additions of the same number. So that means that 2s equals to n times n plus 1. Yes? And so s is equal to n times n plus 1 divided by 2. And so if I had to sum numbers 1 plus 2 plus 3 all the way to 100, the answer is simply 100 multiplied by 101 divided by 2. So it's just 50 multiplied by 101. You understand? So that's why Gauss was able to figure that quickly. Good. Now here is a question for you guys. You have 10 diplomats and they are in a meeting, and we need to know how many handshakes must take place if each diplomat shakes the hand of every other diplomat exactly once. You understand the question? How many handshakes take place if each diplomat must shake the hand of at least one other diplomat? Okay, Rafid says 50. So I have lots of different. How many handshakes take place, guys? Think about it. What you have is 10 diplomats. Each diplomat must shake the hand of each other diplomat exactly once. So how many handshakes take place? Okay, 6 people. Let's see what we have there. Let's see, what is it that we have here? Okay, so some people say 50, some say 45, 90. My God, you have so many answers. Let's now do it together. And then we see 45. Let's do it together. Are you ready? Here is what happens. So diplomat 1 will have to go to diplomat 2, 3, 10 and carry out all handshakes. So there will be 9 handshakes from diplomat 1, right? He now shook hands with everyone. He can stand aside. So now diplomat 2 will go and he will shake 8 hands. Yes, 8 hands. And then the diplomat number 9 will only have to shake an additional 1 hand. So it's summation from 1 all the way to 9. So it's 1 plus 2 plus all the way to 9, which according to the formula, do you understand how we discovered the formula? Would you be able to repeat it? According to the formula we discovered, it would be 9 times 10 divided by 2, which is 9 times 5 or 45 handshakes. Do you understand? Now, again, I think I have some Miriam or some, so how many people? Miriam, right? Do you celebrate Hanukkah? So if so, you have to know the answer to the next question. The menorah, which is Chanukiah in Hebrew, has 9 sockets. I know? Okay, too bad. But you now work in a candle manufacturing plant, so you have to still solve this problem. 9 sockets for Hanukkah candles. The holiday runs for 8 days. On the first day, you light 2 candles. On the second, you light 3 candles. And by the 8th day, you must light 9 candles. Do you understand? So my question is, how many candles must be in this box minimal number of candles in this box to last for the 8 days. Go ahead and calculate. We don't have time. Fast. Schneller. Good, good, Alan. Sie versäumen zu viel Zeit. Fast. That's good. Mirali share good. All right, I'm gonna wait just a few more moments. Good. All right. Here is how we might imagine solving this problem. It's 2 plus blah, 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 all the way to 9, and I would have liked to add 1. So the summation is s plus 1 will equal to 9 times 10 divided by 2, or 45. You agree? If I add 1 to the sum, I will get 45. But I don't need that 1 because I start with 2. So I subtract and then I get 44 candles. Good? We understand? Beautiful. So here is your next task. Yes, Rafid, I'm waiting. Where did the 10 come from again? It's n times n plus 1. Look at the proof. You see, if you add up till n, then if you write the sum, make sure that you actually realize how to, what's the trick here. So if you write the sum in decreasing order and increasing order, when you add, you're adding n plus 1 n times to itself, and then you divide by 2 because of it. Okay, so it's if you add up to 9, it's 9 times 10 divided by 2. That's where the 10 came about. We were adding up all the way to 9, and then we need to multiply by 10 and divide by 2. Good. Your next task, guys, next task is find a formula. Let's see how good you are. Find a formula for summing from m to n of k. So this does not start necessarily at 1. It starts at some other integer, some arbitrary other integer. What is this sum, please? Fast. Is it n minus 1? Well, we need to repeat the full process, okay? What's the trick of the proof? Okay, June, that's not bad. So I don't have time to wait. Let's go and solve it. So first of all, actually I'll solve it this way. Not like what I wrote, I'll solve it slightly differently. Maybe it's easier for you to follow. So the summation from k equal to m all the way to n of k is simply m plus 1 all the way to, and let's call the summation s, right? All the way to n. Yeah? So then what I do is we have s also equal to n plus n minus 1 plus all the way to m. Yeah? Now if I add it column wise, what will I get? Now pay attention to the column. You understand? So what I get is 2 times s equal to n plus m plus n plus m. You agree? Because you see that's what ends up happening here. Plus n plus m. How many copies do we have? That's the question. How many copies? Well, we can think of this as we can see this is m plus 0. This is m plus 1. And this is m plus n minus m. So how many copies we have? We have the copies. This is the 0 copy, the 1 copy, all the way to n minus m copy. Altogether, we have n minus m plus 1 copies. Do you see that? So that means that s, when I divide by 2, will be n plus m multiplied by itself n minus m plus 1 times divided by 2. And you can see the formula works if you set m equal to 1. M equal to 1, it would be n times n plus 1 divided by 2. Back to the lecture. Now it gets a bit more difficult. My goal now is to figure out the sum of the squares. The sum of the squares. 1 squared plus 2 squared plus 3 squared all the way to plus n squared. Okay, are we ready? So if you studied combinatorial analysis, that would be, and something, by the way, that good students, you're welcome to join next semester, because I'm assuming it's going to be online, so you can visit it on Monday and Wednesday. This basically I can immediately figure out what's the answer by realizing that it could possibly be talking about a person of a nondescript age. So you cannot tell how old the person is. He might be 2 years old or all the way to n plus 1 years old, and he has 2 younger siblings. And when I realize that, I can immediately figure out what is, that's what the cool thing about, you see, you study such things. You study combinatorics, and such ideas, they just pop into your head. So this is, I'm not going to go over it because it's combinatorial analysis and we haven't studied that. So the answer is immediately 2n plus 1 times n plus 1 times n divided by 6. We can get it using calculus ideas. So first, recall Pascal's triangle. I was told that in pre-calculus you are taught how to use the Pascal triangle. Not sure if you know how it works, but why it works, but you have learned how to use it. Am I correct? All right. So let me remind you how the Pascal triangle may be used for expansion. So you have 1 1 and 1. Then to get to the next row, you simply have a 1 here, and then you take 1 plus 1, that would be 2, and then 1 here. So the next is 1. 1 plus 2 is 3, 2 plus 1 is 3, 1. So that is the expansion for the cube. Next row is 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then you have 1. So that's the expansion, the coefficients that are expanding x plus y to the power of 4. So for instance, how can I use this line to figure out x plus y cubed very rapidly? So that would be 1 times x cubed plus 3 times x squared y. I just decrease the powers of x, plus 3 times xy squared plus 1 times y cubed. So that's the expansion for a cube without toiling. Good? So here is what we are going to do. We are going to compute a seemingly more difficult sum, namely the sum k plus 1 cubed minus k cubed. So what is that sum? We're gonna compute it in 2 different ways. One of them, I'm going to separate the sum into 2 parts and simplify. So you see, expanding this, well, simplifying it. So it's what is it? It's k1 to n of k plus 1 cubed minus k1 to n of k cubed. So we simplify it. What do we get? We get that the numbers run from, you see, look at it, it's just the summation of 2 cubed all the way to n plus 1 cubed. So I can just rewrite this sum and say this is k equal to 2 to n plus 1 of k cubed. So before I continue, do you realize how I rewrote the summation? Do you see this and that are related? Write in the comments. You see, so what I do is simply I get the meaning. I see, oh, it's just summation of 2 cubed all the way to n plus 1 cubed, and then again encode it in this notation. And the reason I do that is now it's very easy to cancel. So here I can write it as the summation from k2 to n of k cubed plus n plus 1 cubed. You see, I can just take the top number and write it separately. Here, I will take the bottom number and write it separately. And as a result, whatever remains is simplified and removed. So it's 0. So that means that the result is simply n plus 1 cubed minus 1. N plus 1 cubed minus 1 is n cubed plus 3n squared plus 3n. When I simplify it, you understand? Or understanding means that you would be able to write it on your own once you are not watching me do it. That's understanding. Good? So on the other hand, I can expand first k plus 1 cubed minus k cubed. And when I expand it, I see k cubed plus 3k squared plus 3k plus 1 minus k cubed, which is 3k squared plus 3k plus 1. And when I simplify it, I see this expression, which I can expand, and I see 3 summation of k squared times 3 summation of k plus summation of 1. Now I know every part here except for the summation for the k squared, right? That's what we wish to find. That's we get an equation. So here I see this is 3 times an unknown, 3 times n plus 1 over 2. And what is this? I'm just adding 1 to itself n times. This is just n. So the result is simply, well, it is this. It's 3n to the squared plus 5n over 2 plus this summation here. Algebra, nothing special once you see this. So then on the other hand, what is the sum equal to? The summation, this summation is equal to the first calculation, to n cubed plus 3n squared plus 3n. And so then I just solve for this equation. This is my unknown. This is my unknown. And I solve for it and I obtain what's written below. I obtain 2n cubed plus 6n squared minus 3n squared plus 6n minus 5n divided by 6. Upon further simplification, you get the formula n times 2n plus 1 times n plus 1 over 6. So what that means is that if you understood the idea, you should be able to, without looking into my notes, figure out how to expand k squared. When I was taking calc exams, I would also be paranoid that I might not remember the formula correctly, so I always derived it on the exams. That doesn't take time. If you're proficient, if you understand what's going on, it doesn't take a lot of time. I'm gonna release my cat. Just give me a second. There was an exchange of cats. I had a gray cat and now this thing is there. All right, I'm gonna throw it out. Throw the evil spirit out. No more evil spirit. Now everything is good. You're not a fan of this one. I mean, you don't know him. He's, you know, I hold myself from not throwing him out. He really annoys me. So, same idea you should figure out for the k cubed. Okay, same exact idea for the k cubed. Let's just, before we move on, let's very quickly just, before we finish today's lesson, talk about the area problem. Right, so just a few more minutes of your time. Given a curve y equals f of x, the question is, how do we find the area from A to B? Okay, in mathematical notation, we will ask this question this way. Integral from A to B f of x dx. Of course, the reason for the notation will become clear shortly. First, I want to talk about why such problem might be something that you might be interested in. Why would somebody suddenly decide, let me calculate area under the curve? So obviously, probability. Here is a particular example that was interesting. It's an example that is one of the reasons why we sit here like idiots and do online lectures through this digital condom. So the reason for that has to do, one of them is this idea about the spread of illness. And then the question is how dangerous or how virulent is an illness. So here is a particular example. Suppose you wish to measure the prevalence of a certain illness in the general population, right? So for instance, that's what is virulent? Virulent means very, you know, infectious, very infectious. Good. Now, you all hear, my God, we don't have enough tests. Let's do more tests. Test, right? That's what people were screaming. Test tomorrow, in the morning, in the evening, at night. Now, if anybody just looks a little bit at the mathematics, you see how you do that correctly. Here is what you do to estimate how the disease is spreading in the population. So suppose we gather 1,000 individuals and find that 50 of those individuals, we examine those 1,000 individuals carefully, randomly sample 1,000 individuals, and then find that 50 of them have the illness. What can be said about the frequency in the population? How frequent, what is the likelihood of this illness in the population? Now, the answer to it, I will not go into too much detail. It has to do with integration. It has to do with area under the curve. It has to do with the beta distribution. So once you understand how it works, it also relates to integrals. So by the beta distribution, you can see if the sample was done correctly, that it's 99% likely that the prevalence of the disease is between 3% to 7%, given that you found 50 individuals randomly among 1,000. You see, if you took 1,000 individuals. So the point is, it's very stupid to do many tests to figure out how the disease is spreading. You just have to do, what you have to do is do very few tests compared. You don't need to do millions of tests. You just need to do a few tests maybe 1,000, why not, right? And test them carefully and see how many of those people are sick. And then you can do the sampling again. Don't just test everybody. Okay, and that had to do with area problem. Okay, beta function. I teach that in probability. If you're interested, next semester, you are welcome to join. I will explain lots of ideas. In physics, naturally, right? So first of all, obviously probability is related to physics, because if you try to open that book on quantum physics, it's a mixture between a sort of functional analysis and probability theory, right? Probability waves is what they describe. So other even basic classical physics is related to integrals. So let's say, what is the conservation of energy? The conservation of energy is the fundamental theorem of calculus, which has to do with area under the curve, at least in its primitive form. If you have, let's say, potential force involved, right, or some sort of just two transitions involved, that would be a clear Calc 1 type integral. Momentum, force, energy are all statements about area. So momentum, conservation of momentum, force, energy, all those things relate to physics, and they relate to integration. And you can see that if you read the, let's say, Klebner and Kalinkov book on physics. Okay. So when you convert force into kinetic energy, for example, right? So that would be related to integration. So so I'm hoping that at least you believe that this problem of finding area under the curve is of fundamental importance. And so if you do believe that, how do we go about planning it? Do you understand what calculus is doing, guys? Calculus is picking the simplest instance of that quantity that we want to measure and tries to describe everything else in terms of it. So in particular, when I study curves, I want to consider the simplest curve, the line segment, and I describe the curves as a bunch of line segments stuck together. If I want to understand area, what is my pixel? What's my fundamental object that I will be using to describe everything else? What's my pixel, as I call it? What's my building block for the area? It would be an object for which a geometric shape, for which area is very simple to calculate. So what would that be? Okay, what is that? What's the pixel, guys? Simple question. You see, the simplest curve is a line. That's why we use the lines to describe other curves. If I study area, what geometric shape has the simplest area? Why are you all hiding from me, Sadman? Rectangle. Triangle is fine, but rectangle is a very simple shape. Sometimes triangles are preferable. You are right, James. But we will begin with a rectangle. Okay, so you see that why is the area of the rectangle so simple? Because let's say a 4x2 rectangle, one that is height 4 and width 2, it contains 2 times 4 or 8 unit squares. Right? So it's 4 times 2 is 8. So the area of a rectangle is width times height. Good? So we will use those as our pixels. Here is the drawing. You understand what the idea is? We will divide the interval into thin, very, very thin bases of equal size and erect rectangles that will be height of the function. So look at it. The width of that rectangle is dx and the height is f of x. So now you can see what is the reason for that symbol. That means sum up the areas of the rectangles. At some typical point x, the rectangle will have height f of x because it has to fit underneath the curve, and it has width dx. So you see the notation, it's what you call Indian names. It's like Dances with Wolves. It's a name that gives you a sense of what this object is about. It's very useful. So this means sum up all the rectangles, all the areas from rectangles placed thinly between A and B. So that means it's a very thin rectangle. Dx means it's the width of the rectangle is very, very small. Okay, and f of x at any x is going to be touching at the curve because the rectangles are assembled below the curve. Good? So next class, we talk about how to examine this idea. Here, let me just show you a preview. This is, those are those rectangles. You see that those very thin rectangles are building up the skyline. So if you add up the areas of those rectangles, you will have essentially the area below the curve. And a typical rectangle that's positioned at point x has width dx and height f of x. You see in this picture what I mean? Right? So the symbol is very suggestive. It means add up the areas of those rectangles, width times height. I will stop the recording